Today, we are going to discuss the conversion of binary to gray code and vice versa. A gray code is a reflected code. The best way to describe gray code is that of a mirror technique. At first, only one bit is reflected by a mirror. After that, only two bits are reflected by the other mirror. At last, only 3 bits are reflected by the mirror, and so on. That's why sometimes it is named by binary reflected code. The detail will be discussed soon. Illustrate the truth table of binary to gray code conversion. A, B, C, D is represented by binary code as input, where A is MSB and B is the LSB. W, X, Y, Z is represented by gray code as output, where W is MSB and Z is LSB. First of all, in the case of this 4-bit binary digits 0001, to convert this code into gray, the following steps are: Number 1. At first, the MSB of binary code is as same as the MSB of the gray code. Number 2. Now we are going to XOR each bit of binary with a previous bit to get the other bits of gray respectively. As we know, 0 XOR 0 is equal to 0. Here also 0 XOR 0 is equal to 0. And we know 0 XOR 1 is equal to 1. Finally, we get the result, which is 0001 in gray code. The same phenomenon will be applied for the other set of data. The corresponding K-map of W, X, Y, Z has been shown respectively. In W, there is only one group of cell, whereas in X, there are two groups of cells, Y, there are also two groups of cells, and in Z, there are also two groups of cells. The equations of these variables will be W is equal to A, X is equal to B C naught plus B naught C, which is B XOR C, Y is equal to A naught B plus AB naught, which is equal to A XOR B, Z is equal to C naught D plus CD naught, which is C XOR D. Illustrate the digital circuit of W, X, Y and Z. A generates W, B XOR C generates X, A XOR B generates Y, C XOR D generates Z. Illustrate the truth table of gray code to binary conversion. W, X, Y, Z is represented by gray code as input, where W is MSB and Z is the LSB. ABCD is represented by binary code as output, where A is the MSB and P is the LSB. First of all, in the case of this 4-bit binary digits 0011, to convert this code into binary, the following steps are: Number 1. Here, also the MSB of binary code is as same as the MSB of the gray code. Now, we are going to XOR each bit of gray with the previous bit of binary to get the other bit respectively. As we know, 0 XOR 0 is equal to 0. Here also 0 XOR 1 is equal to 1 and 1 XOR 1 is equal to 0. Finally, we get the result, which is 0010 in binary code. The same phenomenon will be applied for the other set of data. The corresponding K-map of A, B, C, D has shown respectively. In A, there is one group of cells. In B, there are two groups of cells. In C, there are 4 groups of cells. Finally, in D, we see there are no group of cells. The equation of these variables will be A is equal to W, B is equal to W XOR X, C is equal to W XOR whole X XOR Y, and D is equal to W XOR X XOR Y XOR Z. Illustrate the digital circuit of A, B, C, D. W generates A, W XOR X generates B, W XOR X XOR Y generates C, W XOR X XOR Y XOR Z generates D. In today's lecture, we have learned binary to gray code conversion and vice versa, K-map of binary and gray code, digital circuits of binary and gray code. With that, we are at the end of this lecture. We will meet again in the next lecture. Till then, learn and practice. Thank you and goodbye.